I found a problem with the website. Yeah, so I don't know, it was Beth or Alex, were you gone when I explained that? The problem with the website? The website that I found out was, when, geez, the marker's dead. The problem with the website is when you looked at the site and you're on, you did the little lesson thing and it took you to general, and then, had a description of general math, and then it had the lessons down here, it was only showing 10 of them. And it wasn't even like the recent 10, it was only showing you day 1 to like September 1st. So what I had to do is I modified it because it wasn't going past 10, it was limited to 10 lessons on that page. So here's how I modified it. Okay? What I basically did is I put a box around this. I know that seems weird that there's only 3 of them, but this is a carousel, it spins. And I put little arrows up here, a little active button. So if you hit the button, like with your mouse, these 3 slide, the next 3 come in, the next 3 come in, the next 3, and you can go to the date. These are dated, and then they're also the sections underneath them, so you know what date yesterday was. And so they're all there now, and then after we're done with chapter 1, which is basically next week, with chapter 1, I think we're going to work on the practices Monday, Tuesday, which you'll get Monday, Tuesday. Then once we're in chapter 2, I'll put chapter 2's box down here, and that'll have its own carousel. And once we're in there a couple days, what I'll do is I'll move chapter 2's videos up, and you'll see that they're up on the top then. The most recent videos will always be on the top. Does that make sense? It's just, I didn't realize the page was limited to 10 lessons only. I had no idea. Like, I didn't even realize that was a thing. Like, I don't know why I can't just put all of them in there, but this actually makes it more clean, because now the top videos are always the newer ones. So you don't have to scroll for like an hour to go find what day we're on. So that's good. So, and then eventually, like when we move to second semester, I might categorize these all into like semester 1s, and I'll dump semester 2s into their own, so you're not always searching through semester 1 stuff. Question?
Do you have a website for each different class?
Yeah. So, yeah.
That's a lot of websites.
It's a lot of websites, it's a lot of work.
Wait, what website do you use?
hsmath.org, but then, it's hsmath.org/general math, or /precalc, or /geometry, so I have...
Have you tried Weebly?
So, I tried Weebly was too limiting.
Oh,
So,
I never used Weebly.
I have a Weebly account, I have a website on there, but I don't like it, I don't even have it published, because I just want to see what it can do. I didn't like it, so, I'm using Squarespace. Squarespace is awesome, never goes down. It costs a fortune to run it, though. Alright, so we're on section 1.8 to 1.9 today. Okay, so 1.8 to 1.9, we are doing the expressions, and we're learning how to simplify with a couple different things. So, let's talk through a couple objects here today. The main thing, we're going to do a couple examples of numerical expressions, and I'll describe what that means. There's a couple vocab terms that we're going to discuss. I hinted at yesterday, but I want to make sure that you are comfortable with, so we have some vocab there. Okay? Vocabulary. After we're done with that, we'll do a couple examples of numerical expressions. Just make sure, like, if we eventually get homework in here, you know kind of how to do it. Which I think we're going to probably get homework. Let's see, it would be probably Monday we'll get homework on that stuff. So you get kind of a weekend for a break. But then, we are going to try to get to the order of operations stuff today. So order of operations, which still applies to expressions, don't get me wrong. Still the order of operations, but we're going to look at the actual order itself. And so we'll do a couple examples. I'll pull a couple examples right from the book, so that you're comfortable with that again, because I do like to make sure that you understand like what we're going over, and then if we're comfortable with that, I'll give you some time if you need to finish up that page 27 today. That'll be after lunch. So no homework today, but you do have an assignment due today. That was at page 27. So I do want to make sure you get caught up, because I know I've been giving a lot of assignments, so I want to give you a couple days so you can get caught back up and back to 0. So.
Has everyone turned it in yet?
I think so, actually. I think there's a couple turned yesterday. I'll pull it back out. I'll go through the names who've actually turned in page 27, if you haven't already. So, that way, but we'll do that after lunch. So, okay, so everyone understand what we're doing here today? Pretty straightforward. Alright, let's get to the numerical expression stuff. Let's do that first. I'm gonna actually put them over here. So, numerical expressions. This is basically the kind of the key concept for what we're doing here. We don't have any variables or anything like that. Everything has a number in it. And expressions, we don't have any equal signs. So basically what you can do is we can simplify these problems down. We can simplify them or evaluate them. That's another key word, evaluate. But just try to refrain from like using the word solve. You don't solve them. You solve for variables in algebra, but we simplify these problems. That's a correct term. I know that some of the other math instructors here, like Mrs. Weisenstein and Mr. Godden, are very, very picky about that choice of wording. So, okay, but let's talk about some of the vocab here, because that's two of the words I want to discuss. I do want to discuss exponents. So, exponential form. I want to talk about how you can actually expand them and simplify them down. Expanded form. So that's kind of one of our key topics, right? That we have exponents. We might have to simplify something with an exponent. So let's start with just kind of a basic problem here. Let's go with like 3 to the 4th power. 3 to the 4th. Okay, this is exponential form. It's a numerical expression. It has numbers. There's no variables in it, so we're fine. We can simplify this thing down. But let's discuss. If this is exponential form, you know, you have a number, a base, right? So, in fact, let me put that vocabulary here. We do have a base. What is the 4 called again? What was the vocab word we talked about yesterday?
Exponent.
Yeah, exponent or power. Yep, exponent or power. Okay, now, that's exponential form because it literally has an exponent. They're not real creative on the name. But, what does this mean? Not 3 times 4. Nope, not 4 times 3.
You take 3 times itself 4 times.
Yeah, that's what we're doing. Maybe that's what you're kind of hinting at. We take 3, the base number, times itself that many times. That's what it means. So that's something we need to be careful on. Okay, because I know when most people look at it, they go, oh, it's 3 times 4, it's 12. It's not 12. This number is way bigger than 12. Okay, so we're taking 3, the base number, times itself a bunch of times. So when you do that, you can simplify this problem down until you get to a final answer. So 3 times 3 is 9. 3 times 9 is 27. And then we take 27 times 3 and you get 81. That's about as far as you can go. That's evaluating that expression all the way out. Okay, does that make sense that it's not the number 12 though? Okay, so it's 3 4 times. Maybe that's the way you're trying to say it, which is correct. I mean, it's 3 4 times in a row. Alright, so that's a numerical expression. That's something that I wanted you to be comfortable with. But what yesterday we talked about was like this idea, like a lot of people don't really wrap their head around what these powers mean. Like what a power 4 means, or a power 5. So if we were talking about distance, where, you know, let's say we did 10 squared, okay, because that's power 2, right? We just say squared instead of just to the 2nd power. What does that mean?
10 times itself.
Yeah, 10 times itself, 2 times, right? So what's 10 times 10?
100.
100. That's a long distance. If you think of like this in terms of distance, you know, going 10 feet squared is actually 100 feet. That's a long ways. Like going from 10 and just putting power 2 made to 100. Okay? This is something I want to discuss. This idea of powers of 10 when you put a power. So if we did 10 to the 3rd power, what does that mean?
10 times itself 3 times.
Yeah, 10 times itself 3 times, which is 10 times 10, which is 100, times 10, which is 1,000. So here's the easy way to think of it. If it's a 10, this only works for 10s. What's the number up top?
3.
That's how many zeros you'll have in your answer. That's just how I think of it. So if this was that was an 8, how many zeros would I have for my final answer? 8 zeros. So your final answer is 1, 2, 3, 4, 5, 6, 7, 8. Right? Yeah, it's 100 million. That was just with the power of 8. Got 100 million already. Okay? I want to show you this in terms of distance. So I got a small video for you. So that's what I want to watch right now. So let's take a look at this video here. Hold on, we need to turn on projector. You guys can't even see this yet. Okay. Good. Alright, so that was numerical expressions, right? Something with powers. Now let's talk about this idea of order of operations and how we can mix that stuff in with our current problems. So these are problems that we looked at yesterday. Times 2 minus 1 to the 4th power divided by 3 plus 6 times 2. Okay. Okay, so this is an order of operation problem, like we discussed yesterday. So the order of operations, we have this little acronym, PEMDAS, okay? Please excuse my dear Aunt Sally, right? So there's 5 acronyms. What we talked about yesterday, what does the P stand for in PEMDAS? Yeah, parentheses, right? I always remember to spell it, parent, and then Hesses after it. Okay, that's any grouping symbol. Well, we have that. You have to do those first, whatever the numbers are on the inside. Then, we have the E from PEMDAS. Exponents. So you have to do those next. So, that's what we just learned here, or we just reviewed, I should say. Where you know you have a certain number times itself that many times. Okay? Then, the M or D. Yeah, multiply or divide. It really doesn't matter which one comes first as long as you go left to right. So we'll kind of look at that. Okay? And then add or subtract is the last one, which everyone pretty much knows that. So that's add or subtract. Okay, so that's your little acronym. Notice the last two. They're grouped together because it doesn't matter as you go left to right. Okay, so let's actually work through this problem. Let's work it out loud and we're going to see what we can come up with. So, first thing, what do we need to do first? Parentheses. What's 2 minus 1? 1. So we have 1 to the 4th power. And I'm going to write everything down. Notice that when I'm transferring this down, like when I'm actually simplifying this thing out, I'm evaluating, I leave everything where it is. Okay, I leave everything there. And all I do is I work on the parentheses and then I write down the rest of the stuff. Okay, we're done with the parentheses now, right? I got rid of them. What's the next thing we should do? Exponents, right? So, because if you go down this list, we're done with the parentheses. We have to do the exponents next. And if there's multiple exponents, you can do those all at the same time. So we have to do those. So 1 to the 4th power is 1 because it's 1 times 1 times 1 times 1, which is just the number 1. So I'm going to transfer this all down. Alright. Okay. We good so far? Okay. Alright, any questions, concerns about the first 2 check marks we've done? Okay, easy. Pretty much. Left or right, what's my next step?
Times.
Say it again?
Need the times that.
Yeah, we have to do these next. This is where it gets tricky. There's a lot of multiplying and dividing here. So you can definitely see the different structures we have. We have to do them left to right. So what's the first one we should do?
3 times 1.
We have to do that first. Okay? So what is 3 times 1?
3.
3. I'm going to write this a little bit bigger. 3 divided by 3 plus 6 times 2. Alright, so all I did first was these two. I multiplied. Now what's the next step?
Divide.
Yeah, we have to divide. Because as you go left to right, it doesn't matter which one you hit first. A lot of people think you always have to multiply. No, I have to divide here. This is the next step that you have to do. So this is going to turn out to be 5 minus 3 divided by 3?
1.
1. And then plus 6 times 2. So, when you take a number and divide by itself, it always makes the number 1, right? You have 1 full pan, that's kind of the idea. Alright, now the last step that I have to do here.
2 times 6.
Yeah, 2 times 6. You have to keep multiplying until we're all done with that. Because I haven't checked it off yet. So 5 minus 1 plus what, 12? Is that 6 times 2? Notice that I had 2 different types of multiplying. We had the little times symbol versus the dot. You mean the same thing. Okay, now that one's checked. We're done. We're done with multiplying and dividing. So now we can add and subtract. Which one do I have to do first?
Subtract.
Yeah, you have to subtract left to right. Because it doesn't matter the order that you do, because that's why I put the word or in between them. So 5 minus 1, what is that, 4? And then you can add that to the 12, which is 16. So I go left to right. Okay, is there any questions or anything that you have on those types of problems? Okay, pretty straightforward I think, figuring out how that works, just making sure that you're going one step at a time. I'm going to give you the rest of the time if you have not finished page 27 here. Try to wrap that up, try to get done, turned in today. I'm going to go through the list who hasn't turned it in yet. You probably already know, but I'm going to go through the list one more time just to make sure. If you have not turned in the page 23, that was due yesterday. So make sure you're getting that turned in, but let me go through the homework. And your grades will be again updated over the weekend, like always. Alright, let's see. Alex, you turned it in. But Alex, I think you only gave me one number. I think you only added the numbers together. And you just gave me the mean. You didn't do the median or mode.
Well,
So you might want to take that back. So I'll give that back.
yeah, I understand.
Yeah. Alright. Jason, you have turned in. I think you gave me all 3 numbers, so that's good. Let's see. Sean, you only gave me the means. So you gotta keep doing the mode and the median number. So the mode, if it happens the most, if it doesn't have a mode, that's not a big deal. So, and I think that's pretty much about it. I don't see any others that people need to turn in. We keep going here and see if anyone else needs to turn it in. I think that's pretty much about it. Jason, you're the only one that actually had that completed. Perfect. And Liz. Oh yeah, so good.